In this video, I'm going to show you some examples of how to find all the factors of different numbers. Remember that factors are numbers that can be multiplied together to equal another number. So for example, 3 and 4 are said to be factors of 12 because 3 times 4 equals 12. 2 and 6 are factors of 12 because 2 times 6 equals 12. And 1 and 12 are factors of 12 because 1 times 12 equals 12. On question number 1, it asks us to find all of the factors of 84. So when I'm doing this, I make a list. And there's not a right or a wrong way of how you make your list, but I use the what I call the upside down rainbow method. A lot of times people do the rainbow method where they connect all their factors above the number. I usually do that upside down, just because I want to make sure that I am not writing on top of a previous problem that I might have shown my work on. So when I start out, I always start with 1 because 1 is a factor of every number. And 1's partner is 84. Factors will always have partners. And then I connect those upside down like this. You'll see that when I'm doing it upside down, if I had a problem right above this, it's not going to be on top of my work. Then I go to the next number above 1, which is 2. And this is where, if you know your divisibility rules, it will really help you. The divisibility rule for 2 is that the last digit in your number has to be an even digit, meaning it has to be 0, 2, 4, 6, or 8. It is a 4, so 2 is a factor of 84. I'll put it on my list and put a comma in between it just so my factors don't run together. Now I need to find the partner with 2. 2's partner, 2 goes into 84 42 times. I'll connect those two numbers and again put a comma in between them. After 2 comes 3. The divisibility rule for 3 is the sum of the digits must be divisible by 3. Well, the sum of the digits is 8 plus 4, which is 12, and 12 is divisible by 3, so 3 is a factor of 84. If you're not sure how many times one of these factors goes into the number, you can always just divide. So 3 goes into 8 twice, and then 3 goes into 24 8 times. So 3's partner is 28. Unfortunately, the divisibility rule for 4 involves the last 2 digits of the number, which in this case is the entire number. So what we're going to do is we're just going to divide by 4 to check. This is a really easy one to divide by 4. You can tell right away that 4 goes into 84 21 times. So it is a factor of 84. The rule for 5 says the number must end in a 0 or a 5, and it does not. The rule for 6 is that 2 and 3 must both be factors of 84, and they are both factors of 84. So 6 is a factor of 84 as well. To find out how many times, I'm going to divide. And it looks like it's going to be 14. So 6's partner is 14. 6 times 14 equals 84. You'll notice that as I'm doing this, the gap here between my factors is getting smaller. Now we only need to check 7 through 13. 7 does go into 84. It's just a basic math fact because 7 times 12 is 84. Now we're up to 8. And 8 does not go into 84 because 8 times 10 is 80 and 8 times 11 is 88. So 8 is off the list. 9 does not go into 84 because 9 times 9 is 81 and 9 times 10 is 90. 10 does not go into 84 because 84 does not end as 0. 11 does not because 11 times 7 is 77 and 11 times 8 is 88. And now we're up to 12, so we have listed all the factors of 84. 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. Question 2 says list all the factors of 45. I'm going to do this down here at the bottom. Start out with 1 and 45. Connect those. 2 does not go into 45 because 45 is not even. The rule for 3 is add the digits. 4 plus 5 is 9, and 3 goes into 9. So 3 does go into 45. And that's one that you probably already know. 3 times 15 is 45. 4 does not go into 45. 45 is not even, and 4 will never go into a number that's odd. 5 does go into 45. That's a basic math fact. 5 times 9. 6 does not go into 45 because it's not, again, not even. 7 does not go into 45. 7 times 6 is 42, and 7 times 7 is 49. And 8 does not go into 45. 8 times 5 is 40, and 8 times 6 is 48. So we've listed all the factors of 45. 1, 3, 5, 9, 15, and 45. Question 3 says, which list shows all of the factors of 26? In this case, because it's multiple choice, I can just start looking for which ones actually have all of the factor pairs. Well, on A, 1 is not paired with anything when it should be paired with 26, so it's definitely out. On B, 2 times 13 is paired together, but 26 is not paired with 1, which it should be, so it's out. On C, 1 is paired with 26, and 2 is paired with 13, because 2 times 13 equals 26. So that looks good, but we need to check if there are any more. On D, 1 times 26 is fine, but 2 times 14 is 28. That equals 28. So this one's out. Your answer is C. And number 4 says list all the factors of 32. We have 1 and 32. 32 is even, so 2 is definitely a factor. 2 is partnered with 16. The rule for 3 tells us to find the sum of the digits. 3 plus 2 is 5, and 3 does not go into 5, so 3 is out. 4 does go into 32. 4 goes into 32 8 times, because 4 times 8 is 32. 5 does not. It does not end in a 0 or 5. 6 does not, because 3 is not a factor of 32. And 7 is not a factor of 32. 7 times 4 is 28, and 7 times 5 is 35. So all of the factors of 32 are 1, 2, 4, 8, 16, and 32. The only other thing that I want to mention here is remember that every factor will always have a partner, a pair, except when we're talking about square numbers. So square numbers like 16, it is 1 and 16, 2 and 8, and then it has a 4 because it's a square number. That 4 is actually partnered with itself. So every number that's not a square number will have an even number of factors, but all square numbers will have an odd number of factors because one of those factors will be partnered with itself.